Welcome to 9.4. This is our homework assignment, which means two things. Number one, you should have taken the notes by now. I'm not going to explain what parametric equations are. That's part of the notes, as well as some practice for these problems. And two, you should have attempted the problems that I'm about to go through here as well. So I'm going to handle this one page at a time, I believe. And here we go. As often happens in sections with new types of functions, we're given some functions and we're asked to match them with the graph. So what I might be tempted to do here is create a little chart, choose a value for t and determine what x and y are. And usually a good idea to choose 0 for t. If t is 0, that makes x 0, that makes y 0 plus 2, 2, so we have the ordered pair 0, 2. Important right here. Not 0, 2, but 0, 2. This should be an x, y. So 0, 2 is not on this graph, not on this graph. It is on this graph, and not on this graph. So I'm pretty convinced this is C at this point. Maybe I would move on, but maybe I just want to double check. Let's try t as 2. That's a little bit random, but I'm not going to jump to t as 30 or something like that. When t is 2, x is 2, and y should be 4. So it looks like 1, 2. It does look like that's it, so I'm pretty convinced C is our answer. 6. Let's choose t, x, y, and I would propose that perhaps many of you would be comfortable doing this in your head. But if t is 0, I get x is 0 squared 0. Y is 0 minus 2, negative 2. Ordered pair 0, negative 2. 0, negative 2, close, but it's not on there. 0, negative 2, nope. 0, negative 2, yep. So I believe it's D, but let's check one more here. Let's go t is 2, and I get 2 squared 4. 2 minus 2, 0. 4, 0, and sure enough 4 zeros on there, so I do believe that it is D. T, x, and y. Excuse me. If t is 0, x is 0, and y is 0, 0, 0, looking like it's this one. Let's take a look. T is, oh, I'm going to jump to 4. I think for obvious reasons. T is 4, and I get x is square root of 4, 2, and y is 4. 2, 4 certainly looks like it could be on there. So B. All right, this morning. T, x, and y. Let's see, can't choose t as 0. But I'll go with 1. If t is 1, x is 1, y is 3, ordered pair 1, 3, and 1, 3 appears like it could be on there. Maybe negative 1. Negative 1 gives me negative 1, 1, negative 1, 1. Appears like it could be on there. So sure enough, I am very convinced that those are correct. And now they just give us one of those. So really much of the same, but I'm going to just go through this and start listing some ordered pairs. If I put in 0, I get 0, 1. So that is not a possibility because 0, 1 is most definitely not on this graph. If I put in 0 here, I get 1, whoops, 0 for t, excuse me. Put in 0, I get 2 times 0 plus 1, 1, 0, and that does appear to be on there, so let's jump to put in 2. If I put in 2, I get 4 plus 1, 5. Put in 2, I get 4. Does it look like 5, 4 might be on there? It sure seems like that's a possibility that 5, 4 is. So this one is in the running. So let's go 0. If t is 0, I get -1, 0, -1, 0, -1, 0, definitely not on the graph. And if t is 0 here, I get 0 plus 1. I get 1, 0, so that could be problematic for us because that one works as well. If I put in 2, let's say, t is 2, I get -3, 4, and -3, 4 is not on, so out, it must be B. Okay, and there are certainly some other ways of taking a look at this. We could say this kind of looks like it's half of a parabola, and we could eliminate a parameter, which is one of the things we're going to be talking about, but not at this point. So let's take a look. 13 through 28. Sketch the curve represented by the parametric equations. Indicate the orientation of the curve. Use a graphing calculator to confirm your results. Okay, so let's have at that one. So let's go ahead and set up our chart. Let's go T, X, Y. Create some values here. If T is 0, X is 0, Y is 0, we get 0, 0. If T is, let's just go to 1, I get X is 1, Y is -4. If T is 2, X is 2, Y is -8, and I'm definitely seeing a pattern here. Let's go one more just to see it. If T is 3, X is 3, Y is -4 times 3, -12. In fact, if T is X, isn't this just the equation Y equals -4X? That's called replacing the parameter. So here is what we're looking for, and I'll show you an easy way to miss a point on a quiz or a test. 0, 0's on here. Let's count by 2's. 4, 6, 2, 4, 6. That gives the reader an idea of our scale. So 1, -4, 2, -8, and our graph looks like this. Now, because time is involved in this, we have a third dimension. This isn't just X and Y. This isn't really a parametric equation is not really, in this case, a line. It's a point on the line at some given time. So like the graph exists only instantly here. It's not just a rope that's been laid down here. So we should give the reader some kind of scaling, like, for instance, T equals 0. At this point right here, 2, 8. That's when T equals 2. It gives the reader some kind of idea how we got there. And we need orientation. Now, this problem does not say that T has to be positive. Oftentimes in parametric equations they are, so the graph really goes like this forever as well. Orientation means what direction is the graph growing as T is increasing. And as T is increasing, we are going in this direction. This arrow means something different than this. This means it goes on forever. This means it goes on forever that way. But really, this graph started from back here and developed in this direction as T increased. So orientation and some kind of labeling to just tell us where we are at some given time, so we have some idea about how fast this particle is moving. Okay, and in part B they say eliminate the parameter, and that's what we did right here. And it was really easy to do because T may be replaced by X. Okay, so here we go. X, then here I need, whoops, excuse me, going to choose T, and here I need X, and here I need Y, and I think I'm going to do these in my head. Not too bad. Put in 0, get out 0 minus 3. Put in 0, get out 1. put in 1, get out 3 minus 3, 0, get in 2 plus 1, 3, put in 2, get out 6 minus 3, 3, get out 4, 5, and you notice we got this pattern. We're going down 3, or up 3, up by 3, y's are increasing by 2 and by 2. I suspect when I put in 3, I'm going to get 6, 7. Put in 3, get 9 minus 3, 6. Put in 3, we get 6 plus 1, 7. So this is just that's an indication that this is linear. We'll go ahead and graph that. I'm going to count by ones here. We got the room to do it. Y needs to get up to 7. X doesn't. Oh yeah, X has to run ways too. Let's see. -3, 1 is a point on the graph. 0, 3 is a point on the graph. 3, 5 is a point on the graph. 6, 7 is a point on the graph. So and oftentimes we're dealing in parametric equations with t is greater than 0. So a lot of times that would be it. Here's my orientation. We're moving along this way as t increases, but this graph could really go that way. T equals 0, and maybe t equals 1 right here. You should show where t is 0 and show another point along there that gives us some indication about how fast the particle is moving. Now, as far as eliminating the parameter, I could do this graphically because I have a y-intercept of 2 and it looks like we're going up 2 over 1. Or up 2 over 3. We could do it that way, but the proper way to do it in most cases would be to solve one of these equations for t. I'm going to solve the first equation for t. And so I'll start it up here. We have x equals 3t minus 3. So t equals, it was x. I have to add 3. And I have to divide by 3. So I get 1/3 x plus 1. And that's what t is. And now if I put t into this equation, I get y equals 2 times 1/3 x plus 1 plus 1. T may be replaced by 1 on 1/3 x plus 1. That's 2/3 x plus 2 plus 1 plus 3. So this is y equals 2/3 x plus 3, eliminating the parameter. Of course it is. The intercept is at 3. The slope is up 2 over 1. So there is page 1 for you. Again, make certain before you move on to page 2 that you've tried the page 2 problems before you go in there looking for some help on these. Good luck, and we'll see you soon.